Please welcome to the stage, President, Cognition, Russell Kaplan.
Awesome. Thank you guys for having me. So quick background on me. My name is Russell. I'm the founding president at Cognition. We build tools for AI software engineering. We started with Devin, which is an AI software engineer for existing code bases. We also recently acquired Windsurf, the agentic IDE. I guess raise your hand if you've heard of Devin or Windsurf. Great, okay, almost everyone. So today I wanted to talk about proactive versus reactive engineering. A little bit more about our company. We got started around 2 years ago, originally as a research lab focused on long-term reasoning and planning. And at some point we made enough research progress that we decided to release it as a product called Devin, really specifically focused on software engineering. And we launched Devin in about March of last year. And since then, we've been lucky to deploy globally with thousands of enterprises and really been focused on working well with existing code bases. There are lots of AI coding tools out there that help you prototype things from scratch. We're very focused on understanding and getting into the details of all the existing code that already exists. And before I talk about the sort of future of software engineering and this shift from reactive to proactive, I thought it would be useful to briefly chat about the history. I guess raise your hand if you recognize this image on the left. All right, like 5% of the group. Yeah, so these are punch cards. So this was like the original form of programming. Punch cards originally were just for storing data in a way that could be processed automatically, and then later you could actually encode programs on them as well. Punch cards were a big deal at the time they were invented. In the 1890 census, we used punch cards for the first time, and it was on time and under budget. This was like a big revolution in how we could process data and information automatically. But we moved up at some point to higher levels of abstraction, and we had in the late 1940s the invention of assembly. So now you could actually program instructions, not having to physically carry around your punch cards, but you could write them digitally and be able to run code on specific hardware. And then we added more and more levels of abstraction. COBOL was started in 1959 and standardized in the late 1960s as something that was actually portable across different hardware architectures, originally from the Department of Defense. So you could do data processing and software processing across a variety of hardware platforms. And the difference between each of these steps was greater and greater levels of abstraction. And even COBOL, we then later evolved. We started programming in Java. Today we program in Python and all sorts of other languages. But I would argue that the entire history of software engineering is really the history of making it easier to tell your computer what you want it to do. And in that lens, AI software engineering is really just the next natural progression on this journey, where we've made it even easier and even higher level to be able to tell your computer what you want it to do. But there is one important difference with AI software engineering versus this history of software engineering, which is that we are now so fast at writing code that the writing code itself is often no longer the bottleneck for software engineering. In fact, instead, what's happening is that all the other parts of the software engineering lifecycle have become increasingly the bottleneck. And depending on who you ask, a lot of time is spent in these other parts of software engineering. A survey from Microsoft and software.com estimated something like 20% of time or less is actually spent writing code for a software engineer inside a large organization. And so what's the rest of what's going on? Well, people are analyzing the existing code. You're making plans for what code you want to write, your design docs, collaboration. And then when you actually do the software engineering, it's not enough to just write the code. You have to test the code. You have to evaluate the code. If there are potential security issues, you got to go discover those and remediate them. And then you've got to deploy it and maintain it. And so there's this whole life cycle. And if you look at the history of how the software development life cycle has evolved, it's kind of evolved organically in response to the constrained resource, which is software engineering time. So of course, we need to plan things out in advance very carefully before we have people go write a bunch of code, because if we wrote the wrong code, that would be very costly and very expensive. We've been living in this sort of constrained engineering output world. And this is the big thing that's now changing with AI software engineering, which is for the first time, we are headed to this world of software abundance. where now you actually can write code way faster than you can review it and can read it. And at first, we're doing things in the same way, but with AI leverage in the code writing process. But what will come next is rethinking how do we actually do the software engineering process from the ground up, given these new constraints and these new opportunities. And that's where I'm really excited about the opportunity to switch from kind of reactive, pre-planned engineering to proactive engineering. And I wanted to show a quick demo of what I mean by this. So traditionally, when you are building a software team and prioritizing what work you want to do, you scope out your work, you make a bunch of tickets, you have 2-week sprints, you assign the tickets, people will do them, people review them, get merged. But with tools like Snyk, we can actually start to proactively identify what work needs to happen as it comes in. And if you have AI software engineers, you should be able to spin these up elastically to be able to do that work dynamically. And so I'll show you an example of a sample code base we made from Windsurf, which is just a walkthrough of Windsurf itself. And this code is demo code, and like other sort of demo code, we ran it through Snyk and we found that there is a security flag in this demo code. And if we look into the code analysis, we find that Snyk has identified a debug mode enabled issue. So in app.py, there is an app.run call that sets debug equals true in this Flask app, which is not a great security practice. So I think in the traditional way, we might have done our own security review in advance and tried to scope, okay, hey, we have to make sure that we're prioritizing review of this application before we release it. And if sure enough, if we look in the code itself in app.py, we can see here there is this debug equals true flag in this repo. But now, because we have AI software engineering, we can actually proactively flag these issues. So what we've done is we've built a Snyk Devon integration that lets you create a GitHub workflow so that whether you're scanning on a regular cadence on a cron job or dynamically based on new pull requests or new commits, every time code is added to your repository and Snyk is scanning that code for potential security vulnerabilities, you can have a Devon be kicked off to go remediate and triage that vulnerability immediately. So rather than having to work this into your sprint or your plan, you can have this dynamically done based in response to the activity of your existing engineering team. And so from this Snyk security scan GitHub workflow, we can see what happens when we actually add new code. There is a Snyk scan, and if we look through what happens in here, in this GitHub workflow, after Snyk is authenticated and it's run a security scan, it's found one security issue, which is then sent to Devon. And this finding that's sent to Devon for remediation, it spins up an AI software engineer on the background. This is a cloud asynchronous agent that can go directly from issue or ticket or prompt to a full finished pull request. So not something that's constrained to be running locally in your IDE with you, something you can spin up in parallel. And to me, this is a really early preview of what I think the future of software engineering really looks like, which is agents being spun up and spun down dynamically all the time, programmatically in response to events, whether they're security issues or otherwise, and then going off and fixing the issues themselves. So let's look at what happens when this actually gets kicked off. On the back end, a new Devon session is created, where on the left here, you can see a prompt that this was written by Snyk and Devon to say, hey, you are a security resolver, Devon. Go fix the security issues found by this Snyk code scan. Here's the context from the specific scan that we run. And we see here there is an application in debug mode. This is the file, and this is found automatically by Snyk. And one side comment I want to make is AI software engineers, they really thrive on existing deterministic domain specialized tools. Snyk has built this amazing library of existing issues and vulnerabilities, and there's really no need to just throw AI at a static code base and say, hey, go find all the security vulnerabilities, when you have really rich existing static analysis built by Snyk and others that can do this automatically. Where AI software engineering can help is actually going and fixing and triaging the issues so that when we're drowning in tens of thousands of alerts, we can have AI take a first pass before human engineers have to spend time going through all these issues. And so here, Snyk has found this issue and kicked off a Devon session. And under the hood, we spin up a virtual machine, a development environment just like a human engineer would have. And we go through, and Devon starts investigating the code and triaging what's going on. It opens app.py. It looks at the contributing.md file here to know what's the right way to make changes. And then it starts making changes. It realizes that, hey, debug should not be true. It should default to false. But if an environment variable sets it, then maybe it's OK to override. It starts running tests. And like a human software engineer, often the tests don't pass on the first try. And that's OK, because when you have an asynchronous cloud-based agent, you can iterate and fix the tests and fix the code based dynamically in response to what code you're seeing change. So Devin will see, hey, there's initially some failing tests, but it will go address that, update the code so that the tests are no longer failing, and eventually result in a finished pull request. And here we now have a pull request. This is from Devin, so it's attributed to Devin, although we do find some IT organizations prefer to attribute them to the engineers who set up these workflows. This question of agent identity and authentication is a really deep topic, but often people want to be able to see, well, what did the AI write versus what did the human write? So here Devin has written a full pull request to fix this security issue, disable Flask by default, and give an overview of the code change itself, the potential risk involved, and a checklist for human review. So even though we have static analysis tools like Sneak and AI code scanning tools, it's still important for humans to be able to be part of the software development lifecycle. And the role is really changing to be a reviewer of code, often more often even sometimes than a writer of code. And here we have a checklist for human review of what exactly we should be focused on, as well as a recommended test plan. As we go through that, we can review it ourselves, we can merge it, and we can kind of carry on our day the same way we would as if we were working with the human colleague. And so to me, what's really interesting about this is not just like a theoretical demo. This is actually being run in production at scale by many, many organizations around the world. One quick example is a large global legal risk compliance and HR technology provider called Mitratech. So they have hundreds of repositories with inconsistent levels of documentation and maintenance, given that they have a massive business that they've got to support globally. And what they found is that by onboarding AI software engineering agents like Devin, they can get rid of a lot of the first round of engineering toil that exists. And some of the most important engineering toil that exists is in security issue remediation. So by embedding Devin as an autonomous teammate in their existing software development lifecycle, they plugged Devin in and they pointed it at the backlog of automatically discovered security issues, and they fixed 250 open security issues on day one. And mind you, these are not P0 critical vulnerabilities, but these are things that should be fixed. All else equal, it's been hard to prioritize because we don't have the engineering capacity to ship as much code as we would like to ship. And once you get through that initial one-day backlog, you can set up this integration so that you're continuously keeping your code up to date, remediated, and secure as new changes come in. And the result after a measurement before and after this set of changes is that new tech debt can be resolved about 85% faster with this type of AI agent deployment. So in the last minute or two, I just want to briefly talk about what we see from our vantage point as far as what's coming for the future of software engineering. And I think the best description I've come up with is that we are really headed towards a golden age of software engineering, where we will have software abundance by default. We might even have software that's good by default. Even most software today is not that good. But as AI gets better and better at programming and we unleash it on more and more of our digital problems, we could have software that's good by default, that's abundant by default, and really give leverage to the humans for overseeing what should we be working on, reviewing the code that's being written. And the role of the human software engineer, we already see changing in thousands of these organizations around the world to almost like a tech lead manager of AI. You are now still, you're still in your editor solving the hardest problems yourself, but for simpler tasks, for first-line triage, for initial engineering toil, you're delegating these asynchronously to a team of AI coding agents, to a team of Devins, and you're reviewing the work and coordinating it together. And what this means is that we can now dynamically spin up and spin down our team sizes on demand in response to external stimuli. And so, imagine hiring a full engineering team just for one class of issues inside the CI loop of your development lifecycle. That's basically what's happening already with AI software engineering agents. And this is allowing us to start to tackle these security issues proactively instead of reactively. I think the last really kind of interesting two learnings from these real-world large-scale deployments of AI coding agents are that rolling these out based on use cases is often more productive than rolling them out based on individuals or teams. because some use cases have massive, easy to measure ROI, and some are harder, and some aren't as good of a fit. For example, if you have a flood of Snyk alerts and you need to go remediate them and take a first-line pass, maybe tens and tens of thousands of issues in your large code bases, this is a really, really good use case for AI. And as you roll it out in your organization, the other thing we've learned is that every company is completely different. And so you might have your own proprietary frameworks, your own specific ways of doing things, even your own custom programming languages. And having a centralized knowledge base that Devin can proactively contribute to, that your human engineers also proactively contribute to, makes these agents more and more customized to you over time. So if you're interested in trying this out, this is kind of live in Snyk and Devin. You can go to tinyurl.com/snyk-devin, and you can see the documentation for setting this up yourself. Thanks so much for having me.